Hello and welcome back to Chapter 11 Lecture Notes. And so in this one we're going to cover direct labor variances and controllable overhead variances. Okay? So we can say over here our labor rate variance is going to be the difference between our actual wage rate and then the standard wage rate multiplied times the actual number of hours. So similar, and then this would be our price variance, okay, but we call it labor rate variance. And then this is our quantity variance, which is our labor efficiency variance. And that's going to be the difference between the actual number of hours worked and then the standard labor hours allowed, okay, multiplied by the standard wage rate. So that's similar to the quantity variance. So we're going to use the price variance formula here and the quantity variance formula here, okay. So just as like we saw before, we made 5,000 suits, and then our cost of labor, we used 10,500 hours to make those 5,000 suits, and we paid each employee on average $20 an hour. So now what we can do is we can use our price variance formula. So I'm just going to show this sheet once. We're going to use this formula for the labor rate, and we'll use this formula right over here for the labor efficiency. Okay. So when we continue on, we look at our price variance formula, our AQ times our AP minus my AQ times my SP. So how many hours did I actually use? 10,000. How many hours did I use, and how many hours did I pay for? Now these two are going to be the same, right? That's different than the direct materials, where the number that you the amount of materials that you bought could be different than the amount of materials that you used. In this case, the AQ will be the same because if they work those number of hours, we have to pay them. Okay, so we're going to say our 10,500 hours that we paid for times the actual price of $20 an hour minus the 10,500 hours times the standard price, and then we have to look back over here at our standard cost card, and it's $18 an hour times 18. You come over here, and that gives us a variance of 21,000. And is this going to be favorable or unfavorable? Well, you paid $20 an hour when you should have only paid $18 an hour. Costs are higher than what they should be. So it's U for unfavorable. And then I'll go ahead and do my labor efficiency variance, which is calculated using the quantity variance formula. So it's going to be our AQ times our SP minus our SQ times our SP. Our AQ is the number of hours used, 10,500 hours, times the 18. Minus our SQ times the 18. Now again, similar to the problem that we had with the direct materials variance, we're not given SQ, but we can calculate it out. You can say we made 5,000 suits, and each suit should have taken us 2 hours to make. Okay, so that means we had 5,000 suits, each suit 2 hours, means we should have done 10,000 hours. Okay. So we come over here, and when we calculate it out, we get 9,000. Is this favorable or unfavorable? We used 10,500 hours. You should have only used 10,000. That's unfavorable. So now what I can do is I can calculate out my overall variance, just shown right over here. I can take that 21,000 U plus my 9,000 U, which is going to give me the 30,000 unfavorable. Okay? So we talk about some additional points over here on our direct labor, and that's a typo. That should be our direct labor variances. Okay, we could say an unfavorable labor rate variance can be caused by assigning skilled workers to a production process. Okay, the standard cost could have assumed that unskilled workers can complete the job. The potential labor efficiency gain of potential greater efficiency of higher skilled workers might result in a favorable labor efficiency variance, though, to set off the unfavorable labor rate. So basically, remember with the labor rate, you paid more than what you should have. Okay. Another one could be a new contract. And so in that case, we have to update our standard cost. A favorable labor rate variance could be used by assigning lower skilled workers to do the job. That means that we had lower skilled workers who didn't cost as much, and they still do the job pretty well. Okay. On the other hand, the favorable labor rate variance could be offset by an unfavorable efficiency variance because they're unskilled. We didn't pay them as much, so then they take longer. Okay, An unfavorable labor efficiency variance means that the workers are spending too much time. They took too long to make the products. That could be caused by using unskilled labor, okay? Which in that case could call the labor rate could be favorable, but your labor efficiency would be unfavorable. A favorable efficiency variance basically means that they're working faster than what we thought they would be doing. They're making the products faster than what we thought, okay? So that concludes kind of our basic discussion of our labor rate and labor efficiency variances and direct materials quantity and direct materials price variances. So now what I want to go through is to calculate out, is to work on our overhead variances, okay? So a little bit of review here on overhead. Remember that manufacturing overhead is going to include both fixed and variable components. An example of a fixed manufacturing overhead cost would be the production supervisor salary. An example of a variable overhead manufacturing overhead cost would be indirect materials. Remember that as we have that fixed overhead, the rate will decline for fixed overhead or any fixed cost as the activity level increases. Well, on variable though, that's going to stay constant, okay? Due to the fixed cost unit behavior, our average overhead cost is going to decrease as we increase production, okay? So basically that's because the fixed costs decrease as activity level increases, so the overall cost per unit will decrease as the activity level increases. So remember that we actually have to develop a predetermined overhead rate. And the way we do that is we take our estimated amount of total overhead, which includes variable and fixed overhead. Remember, the numerator would be our overhead. This overhead would be our variable and fixed overhead. And we divide that by the allocation base. Now, in order to do these two, we first have to select a level of activity. How much do we think we're going to make? Do we think we're going to be operating at 80% capacity, 70% capacity, 90%, or 100%, or somewhere in the middle there? So those are just numbers that we could choose. You could have 85%. But in that case, what you have to do is you have to say, well, at 85% capacity, what's going to be our total labor hours, or whatever our allocation base is, and what would be our total overhead at that 80% capacity, okay? So this would give us our predetermined overhead rate. So let's assume we have our company GMAX and we predicted we use an 80% capacity level. So in that case, our predetermined overhead rate would be $2 per hour. So what we say over here, if we think we're at 70% capacity, we're going to make 3,500 units. And then our total variable costs, our variable overhead per unit is $1, okay, which gives us 3,500. And then our total fixed costs, our estimated total fixed overhead is going to be 4,000. Our total factory overhead will be 7,500. We apply that based upon direct labor hours. We're going to have 3,500 labor hours. Gives us 214. This would be our predetermined overhead rate. Now in this case, we selected the 80%, so this is the one we're going to go with. So we say that means we make 4,000 units. Our overhead, our variable overhead per unit, we estimated $1. So that gives us our $4,000 of overhead costs, and then see our fixed costs stay the same, $4,000 in each case. But our total variable costs will increase. Our total variable overhead increases because it's a variable cost. So then we have total $8,000 of overhead costs, and we're going to have our 4,000 labor hours, okay? That gives us $2 per labor hour. Then take a look at what happens to the predetermined overhead rate. As you produce more, it keeps going down because this fixed overhead stays the same, and it's spread out over more labor hours, okay? So the first thing that I want to talk about before we even talk about the controllable variance, okay, the controllable overhead variance is just to calculate out our total overhead cost variance, okay? So if we come back over here, the way we can calculate out our total overhead cost variance is by taking our actual overhead that we actually had minus the standard overhead applied, okay? So we say over here during the month, GMAX produced 3,500 club heads working 3,500 direct labor hours. So that means they operated, okay, they actually operated, okay, at 70%. They actually operated at 70% capacity. But remember, when they actually calculated it out, this $2 predetermined overhead rate, that was for 4,000 hours. So they operated below capacity, okay? And this, so then what we can say is our actual overhead is $3,650, and actual overhead, actual fixed overhead was $4,000. So we can say our actual overhead, our total actual overhead incurred, total actual overhead incurred equals our actual variable plus our actual fixed, which is our 7650. 3650 plus the 4,000. Okay? And then we're going to come over here, our standard overhead applied. The way we would figure that out is we would say, okay, they worked 3,500 hours. So when they're going through and applying overhead, remember, they calculated the predetermined overhead rate at $2 per hour, which was based upon 80% capacity. So what they would do is they would go 3,500 times the 2 gives us the 7,000. That's how much overhead they applied. Okay? So when we look at the total overhead cost variance would be equal to 650, the 7,650 minus the 7,000, and that would be our unfavorable because actual is more than standard. Now the problem is with our overhead cost variance is that this total overhead cost variance can have some of this variance can result from volume, and some of it can be controllable. Some of it is because we had more or less volume than we thought. So in this case, we had less, right? Because we thought we were going to be 80%, but we're actually at 70%. And then some of it could be that our variable costs or our fixed costs were just higher than what we thought if we can isolate out volume. So what we want to do now is to calculate out our controllable variance. So we're going to out-analyze this OCV. We're going to divide that into controllable and volume. So I want to focus here. So the controllable variance is going to be the difference between the actual overhead incurred and then the budgeted overhead based upon that flexible budget. Okay. So in a prior chapter, we talked about flexible budgets, and this could be controlled. So the way we actually go through, we calculate this. We take our actual overhead at the flexible budget level of overhead for the actual level. Pardon me, our actual overhead minus the flexible budget level of overhead for the actual level of production. So we say our total. We're going to say our total overhead flexible budget. That's what we need to calculate out first. And then what we would say is if we look back over here, we're going to say this is a different example. This is our Vulcan polymer. So they expect $15,000 of fixed overhead and then $20 of variable overhead per unit. Assume that they actually produced 450 units. So in that case, we take our 450 units times the 20, because remember what we're assuming, right, is that they should still, that their variable overhead should be $20 per unit, okay, times the 450 units. This would give us our total. This would say, this is how much variable overhead you should have had at 450 units. And then how much total overhead should they have had, how much fixed total overhead should they have had at 450 units? $15,000. Because remember, fixed overhead stays the same. Plus $15,000 means that at making 450 units, they should have had $24,000 in overhead. And then we say, well, how much actual overhead did they have? They had $23,000. Okay? So then we can come over here and we can say our actual overhead, following the formula, minus the flexible budget, minus $24,000, gives me $1,000. And remember, we're going to show this as absolute value. Is this favorable or unfavorable? Well, actual is less than what you should have, so that's favorable. Thank you.